Hey everyone, I'm Nelson from the Gradle team, and I'm here to talk about keeping your Gradle builds in top shape. So this is not a talk about improving your build speeds. I've given a bunch of those talks before, but this is about keeping your builds in top shape. There's some seats in the front if you guys are looking. I'm also super happy that so many of you guys are here. This is really good to see. So yeah, a little bit about me before I get started. I work at Gradle Enterprise as a lead solutions engineer. I was previously an Android engineer, just like most of you here in the audience. I've worked on large Android projects at companies like SoundCloud and Square. I've also worked at small startups, and I'm also a Gradle plugin maintainer. I work on Fladle, which is a Gradle plugin to easily scale your instrumentation tests on Firebase Test Lab. And I also work on the Gradle Doctor, which gives you actionable insights for your builds. So as a solutions engineer, I see a lot of builds. Android builds, Gradle builds, Maven builds, from 10-person teams to 1,000-plus teams. And what we do is we optimize and understand builds, we help increase build stability, and we preach developer productivity to all our customers, because of course we love being productive. Also on the solutions team, some of the work we do is improving the Gradle ecosystem. So whenever we see issues with tools and plugins that our customers use, we go and fix them on GitHub. We also meet with Google and JetBrains to prioritize the top issues that are facing our customers. Yeah, so that's a little bit of background. So when it comes to Android development, as you know, you can work on features, and you can work on tech debt and infrastructure things. And so, yeah, of course, there's many other areas that you can work on. But I'm here to argue that in tech debt, you can, of course, refactor your code, build infrastructure, things like that. And you can also work on improving your builds. And slow builds are also tech debt. But it always pays off to work on them, because slow builds are a lot of waste. This is a simple calculation. If your builds have 60 seconds of wasted time, and you have 50 builds per day, which is something typical for an Android developer, and let's say you're working on a 50-person team, that equals 42 hours lost per day. 40 hours, that's a typical work week. So basically, and this of course doesn't include lost time in focus and things like that. And with 42 hours, you could hire an engineer. That's a full work week. So that's why, and if you multiply that times an entire week, you could hire 5 new engineers, right, without recruiting, without onboarding them, things like that. There's a link at the bottom here, gradle.com/ROI calculator, that helps you calculate the value in time wasted on your builds. You can just plug in numbers like how many CI builds you have and things like that, and it'll give you a hard $ number of how much time you're wasting on your builds. So yeah, this is why it always pays off to work on slow builds, but also why it's very easy to justify working on slow builds. It's money. Developer time is money to companies. Okay, so yeah, I work on the Gradle Enterprise team. There's a link to Gradle Enterprise trial if you're interested. But just to get a feel for the audience, how many people here have used a build scan? Okay, a good number of you. That's good to see. So hopefully the slides will be relevant. And how many people here are Gradle Enterprise customers? Okay, a smaller part of that. That's what I expected. All right. So because I think, yeah, a lot of people haven't seen Gradle Enterprise, I just wanted to give a quick demo. We have a bunch of open source instances of teams that use Gradle Enterprise. You can get a link to all of them right there, or if you Google Gradle Enterprise open source software projects. But I'm going to do a demo with the Android X Teams instance of Gradle Enterprise. You can also browse to it in your browser by going to that URL right there. And this is their instance. I'm just going to not mirror displays for a second. Yep. Okay, so yeah, if I go to that website, I see all the scans from the team, and this is just to give context for the presentation. There's a lot of features here I'm not going to cover. So if I wanted to, say, see all the CI builds from the Android X team, I could add this filter. Now I'm looking at CI builds only. If I want to see local builds, I can see what each developer built. I can see their failed builds. I can see their successful builds. I can filter builds by specific tasks, like debug Android test. And then I'll see only the debug Android test builds. There's also custom values here and custom tags. This is also something that'll be relevant for the presentation. So local, for example, was a custom tag that I filtered on. I can also filter on any custom values that I add to the build. And I'll get into how you can add those in the presentation. So yeah, I think that's all I wanted to do for the demo. Let's get back to the presentation then. And feel free to browse that at your leisure whenever you like. Okay, so every Gradle talk has to start with build caching, right? So just to give a little overview of what build caching is, let's say we have a Java compile task. It has inputs and it has outputs. Those inputs, just to briefly summarize, some of them are source files, some of them are your compiler arguments, some of them are your dependencies, and there's many other things here. I'm just simplifying it just to illustrate this. And you have outputs. In this case, for the Java compile task, you have class files. Those are the outputs. And any task can be made cacheable. The same is true for the Kotlin compile task. And these inputs, the source files, the compiler arguments, and the dependencies, those form what is the cache key. If any of those changes, the cache key changes. And therefore, you can't retrieve that output from that same build cache. Or, yeah, it's like a hash map, right? You have the key, you get the value. The value is simply the zipped up class files, and that's put in the build cache. And that's what you get back when you look up a task output in the build cache. All right, so the first thing I'm going to talk about on how to keep your builds in top shape is what we call the build validation scripts. This is something our team has been working on to help understand why your tasks are not up to date and why they're not cacheable. So there's 5 scripts. One is to verify up-to-date checking in your Gradle build, also known as incremental build. The second one is to verify local cacheability, that is to make sure that you can get cache hits for your local builds. The third one is called, it's to verify cache relocatability, that is that the same build run from different directories will get cache hits. The fourth one is to verify that your CI builds are getting cache hits. And then the fifth one is to make sure that your local builds can pull from the remote build cache. And once you've completed all these scripts and looked at them, we say your build is fully cacheable. So there's 5 scripts, and this is their names. They're named just as what exactly they do. And I'm going to dive into each one of them and how it works and how it gives you the results. So yeah, there's 2 ways to run these scripts. You can run them with the interactive mode, and they guide you through and explain everything, and that's with the -i flag. And then the second way to run it is via the command line, where you pass all the arguments, such as your project. And I'll get into how exactly that works later. So if we look at the first build validation script, we call it validate incremental building. What it does is it disables the build cache completely, and then it asks you to run the build with a typical task invocation. So you tell it what task to run, and it will run that for you, including the clean task to clear all the outputs. Then it runs the same build again, but without the clean task. And then you have to determine which tasks were still executed in the second run and why. And then you assess which of the executed tasks are worth improving, and you fix them. So that's what you do with the first experiment. So the first 3 steps are automated. That's the execution of it. Fixing your build, that's not quite yet automated. That's what you have to do. So if you were to run this manually, this is what it would look like. Gradle W, clean assemble, -- no build cache. And the second build, Gradle W, assemble, -- no build cache. And then you get a result when you run the scripts. This is what it looks like. And I'm going to dive into each piece of that here. So the first thing is the project name. In this case, I ran a sample against the Android cache fix plugin. The next is the Git repository. The scripts will check out the code from this Git repository that you specify with the branch and the Git commit ID. And that's to ensure that every time you execute these scripts, you're going to get the exact same result. So if you want to investigate something or fix something, you can rerun the experiment, and it will give you a reproducible result that you can rely on to fix the build. Projector, in this case the root directory. This is if you have a complicated project setup where you want to execute in a subdirectory. Gradle task, right? In this case, we ran the assemble task. We didn't have any special Gradle arguments. But yeah, then now we get to the more interesting parts of the output. So there's the experiment ID. This is actually added as a build scan tag. You can also do this manually via your build scripts, buildscan.tag in a string, or you can do it via command line system property, -d scan.tag. And what this does is, as I was showing earlier, when you're looking at the build scan list, you can filter for executions of the first experiment by typing it in the tags field in your Gradle Enterprise instance. The next thing is the experiment run ID. Every execution of the experiment will have a unique run ID that helps you identify when you're looking back at a specific execution of that experiment, and that'll be added as a custom value, so you can look at it later and just get that specific execution. The next is the artifact directory. So this is all the outputs of every build, or yeah, the whole output of the whole build tree. If you look at that directory, you'll have all the executions of the output of the first part of the build and the second part of the build. Why is that useful? Well, let's say you had a build cache miss or a difference in the output. You could then go and examine that very easily. So for example, let's say you had a difference to a class file. You could take a look at what that difference was. Or if the difference was in a Java file, you could very easily look at that. Then you have the build scan, the first build, and the build scan of the second build that you can click on, and it'll take you right to that build scan. Next, we have a series of investigation quick links. These are links to the second build scan that take you to the task execution overview. This is the overview page in a build scan. That'll show you which tasks were avoided and which ones were up to date, as well as which tasks were executed. The next link is the executed task timeline. And so what we want to see here for a successful result is 0 executed tasks. Because we didn't change anything in the build, the code is exactly the same, nothing should re-execute. Now I have here an example of a build that did re-execute tasks, what that would look like. It would say 3 executed tasks. It tells you how much time that took. And then for each task in the timeline, you can click this little box, and it'll tell you exactly why that task ran. In this case, it re-ran because the input property changed. If you want to know more, there's the task inputs comparison, and that compares all the inputs to all the tasks in the entire build. When you have a successful result of an experiment, it says the 2 builds have the same inputs for every task, so nothing to do. But in the case that there are differences, it'll tell you which input to which task was different, whether that's a file property, or a value. In this case, we can see that there was a timestamp that changed. Timestamps are one of the most common reasons why builds are not up to date, as well as version numbers that are dynamic. You can also manually do a task input comparison by clicking on two builds. Hopefully that's visible. Now it looks like the contrast is not so good, but yeah, you just click the button in the sidebar on two builds, and then you'll get to the task input comparison. But the quick links make it very easy to do that. So the last part about the validation scripts is the command line invocation. So once you run it with interactive mode, it'll tell you how you can rerun that experiment just by executing that command. So in this case, -r is the automatic mode. You tell it the GitHub repo, you tell it the task, and it will rerun the build twice. So yeah, that is a summary of the output of the first build script, or build validation script. And yeah, that's the command line if you wanted to execute. You could actually, you can check it out and just run that command and you'd get the same results that I got. All right, so now let's go to the second script. This one is about the build cache. The build cache is different from the up-to-date checks because the up-to-date checks just check that the outputs are already in the build output directory, whereas the build cache is putting entries in the Gradle home, which contains the build cache. So the first thing you do is you enable the local build cache, and you clean the entire build cache to make sure that no outputs from any previous builds affect the execution of this experiment. Once again, we want the experiments to be reproducible every time you run it. And then you run the build twice with the clean task. Then once again, you have to determine which cacheable tasks were executed and why. You assess which of them are worth improving, and you fix them. Once again, steps 1 to 3 are automated, 4 through 6 are manual. If you were to try to run this on your own, this is what it would look like. It's the same as experiment 1, except the second build is also a clean build, so that all the entries are pulled from the build cache. This is what the output looks like. It's exactly the same as the first experiment, except there are some more investigation quick links here. These are the ones that are added here. These are executed cacheable tasks, as well as executed non-cacheable tasks, and the build cache statistics page. What this is just sometimes you also want to take a look and say, okay, this task was not cacheable. Let's try to make it a cacheable task. The third experiment is where it gets interesting. It's exactly the same as the second experiment, except that the second execution is run from a different directory. Many Gradle tasks often have absolute file paths as inputs, and this helps uncover that. And then once again, steps 4 through 6, you have to improve the build. Whoop. Okay. The fourth experiment is very similar, except you run it on CI. So in this case, the validation script does not help you execute your CI build. It simply helps create the summary by giving it 2 build scan IDs. And then once again, the steps, yeah, all the steps are manual in this case. The last one is where it's really interesting is you run a build on CI, and then you pull it. You run the same exact commit locally, and you hope that all the tasks come. This is where we uncover a lot of issues related to different JDK versions, different operating system versions, line endings, things like that, that cause, or even environment variables like the Kotlin incremental flag, which I saw with a customer a couple weeks ago. It was enabled or disabled on CI, but enabled locally, and caused none of the tasks to come from the remote build cache. Okay, so that's all fun. You run these scripts. We're automating the process of discovering cache misses, but you can also automate the process of executing these scripts. So there's a GitHub action. Here's a link to it. And you can use this GitHub action to run the script. So the first part of it is to use the download action to download the scripts. Then you run experiment 1. You give it the Git repo, the Git branch, and the tasks you want to run. There's, of course, many other options. Same thing with experiment 2, and same thing with experiment 3. Now, experiment 4 and 5, we can't automate because that involves running on your CI system and running on a local build, which are 2 different machines, so that's not possible. But yeah, that's how you can automatically run them. So we recommend everybody just runs them once a week. If you have GitHub Actions, that's exactly how you can do it. If you use other CI systems, you can just run the scripts on them. It's pretty straightforward. We run this automatically for the Android X team, as well as all the open source projects that we have. There's a link to one of the runs. And here's just a sample output from the Android X team, experiment 3. That GitHub link should take you to it. And I'll have a link to the slides later on, so you can explore this all on your own. But that repository, Gradle Enterprise OSS projects, you can see all the executions, all the automated experiments that we're running against all our open source projects. OK, so now we're getting into another part of the talk, which is about the export API. How many people have used the Gradle Enterprise Export API? We've got 1 person here, maybe 2. Cool. Well, it's probably not so fun to use. It's SSE-based, real-time streaming, has JSON events, but there's no event model, so you don't really know. You kind of have to just poke around in there to figure out what's happening. And yeah, it's a bit clunky to use. Yeah, this is a sample use of it. You get builds, and then once you get the build ID, then you ask it for all the events, and it just gives you all the events in the entire build in a big, giant build event object. OK, it's not very fun, but there's a new Gradle Enterprise API. And I know everyone is super excited about Gradle Enterprise APIs. That's what you came here, right? But it's really nice because it's a REST-style API instead of a streaming-based API. And it's based on OpenAPI, which allows you to easily create models and clients. And it has a build API and a build cache node API. And it will eventually replace the old export API, but it's missing raw build events. So this is what the documentation for the API looks like. It's really nice. But yeah, the fun part is use cases. So let's say you wanted to find the projects that you have connected to Gradle Enterprise with the longest build times. Or let's say you wanted to rank your teammates by the slowest average build time. Or let's say you wanted to find all the builds on your team with remote caching errors. Or find the slowest tasks of your entire project. Or the longest non-cacheable tasks in all of the projects. So I'm going to get into some cool samples on how to do it, because it's very easy to do with the new Gradle Enterprise API. Because Swagger will generate the models and the client for you. Before, we didn't even have models. And this is how you do it in your Gradle build scripts. So you apply the Kotlin plugin, you apply the OpenAPI generator plugin, you tell it the OpenAPI specification file, in this case just the URL to the Gradle Enterprise OpenAPI specification, which is a YAML file available on the internet. You can also download it if you like. You give it the output directory where you want to generate your models and your clients. And then you give it some parameters. So the first one, you tell it, I want a Kotlin client. You give it the specification file, tell it the output directory, you give it the package names for your clients and models, and then if you want a retrofit client that uses coroutines, this is how you do it. All the code is generated for you, a retrofit client that uses coroutines. Very easy. All right, so once you have the client, this is how you would use it. You give it your Gradle Enterprise URL, give it an auth name, that's just the name of the parameter, and a bearer token. The bearer token is your Gradle Enterprise API access key. You create the service just like you would with any retrofit style service, if you're familiar with that. I assume this is an Android crowd, so most people are familiar with retrofit. But it's OpenAPI. If you don't like retrofit, if you like Apache as your HTTP client, it'll generate an Apache client for you. If you like just plain OKHTTP, it'll generate that for you. And then, yeah, the models are created for you if you want all the builds since 1 hour ago. You call build API.getBuilds, and then boom, you have builds. You can print them out just like that. So the output of this looks like that, just a list of builds, build tool type, and build tool version. So yeah, that is the getBuilds API. There's 2 other APIs available to you. There's the getGradle attributes and the Gradle build cache performance. So what can we do with the Gradle attributes API? It'll get you all the things like build scan tags, build scan values, settings, build options. So you can go and find out, hey, one person on the team has the build cache disabled. The next one is the getGradle build cache performance API. This one will get you all the information about which tasks executed, why, how much avoidance savings you have for every single task that executed as part of that build. All right, so let's say you wanted to get the project with the slowest average build time. So let's say you have your backend team, your front-end team, and other teams connected to Gradle Enterprise. This is how you would get the project with the slowest average build time. You take the list of build IDs, and you call the getGradle attributes API. In the getGradle attributes API, that has the root project name as a value. So you group all the builds by the root project name. You map the project name to all the builds that are part of it. So then you have a list of project name to builds. And then you average it by the build duration. It's super easy to do in Kotlin. That's why we all love Kotlin. Sort it by descending and print it out. Easy as that. So when you do that, you get a list that looks like this. And then you can say, OK, this team is what we need to focus on. This is a fun one. User with the slowest average build time. I did this at Gradle, and it was the result was kind of interesting. Let's go into how to do this. It actually works very similar to the project one that we just did. Get Gradle attributes, group by it.environment.username. You map it, usernames, average build duration, sort by descending, and print it out. Almost exactly the same code. Now, of course, these results here are just kind of made up. But yeah, when I ran it at Gradle, it was really interesting because what we found out was, yeah, a lot of our builds are just starting up servers. So those builds will be as long as I kept the server around. And so the front-end team, who obviously spins up servers, had the slowest build times. And they're like, what prize do we get? Well, I don't know. But yeah, that's it sometimes leads to interesting results. Tasks with the highest negative avoidance savings. So this is really interesting, especially in Android teams. A lot of tasks on specific Android teams have negative avoidance savings. What are negative avoidance savings? That means it takes longer to pull an entry from the build cache than it would take to re-execute. So you query the Gradle build cache performance API. You filter by all the tasks where the avoidance savings is less than 0. That is, it's negative. Group by the task path. And then you map it. This is the same map we did before by the average. And then you sort it, in this case, by the average time. And then you print it out. And for example, this is really interesting because last week I was dealing with a customer where all their Android unit test tasks had negative avoidance savings. And when we took a deeper look, we found that it was because they were including a 40 megabyte artifact in their Android unit test task, which caused all of them to just take, and it was not a very compressible artifact, so it took a long time to download from the build cache, even with a fast internet connection, and it made it have lots of negative avoidance savings. User with the most build cache errors. Now, I'm just going to put up the code. I'm not going to dive into all these, but this one's also really interesting if you have someone that has a bad internet connection or someone working remotely in a country with not very good internet connection. this often helps you understand, okay, which teammates should have the build cache disabled. Here's another one, project with the least avoidance savings. If you have lots of projects and you want to know, hey, where should I start optimizing? Out of all the projects connected at my company, you could use this to look at that. All right, I'm just taking a look at time. So builds with certain tags, that's how you can do that. We also have something we're working on is called the project summary that kind of summarizes the #1 task that you should work on in a given project. Here's kind of a sample of that at Gradle Enterprise. So here, we found one of these tasks had a miss rate of 100% on our team, so that's something we could investigate, whereas this other one had a miss rate of only 9%. Cool. I'm just going to talk quickly about some Gradle Enterprise Android features, because that's always fun for Android team. One is you can find your slowest tests in the Gradle Enterprise test dashboard. You can learn which of those tests are flaky with the flaky test insights. Android tests, they're always flaky. And I'm also here to tell you that you can upload your Android instrumentation tests to Gradle Enterprise and in your build scans, which, yeah, helps you understand which of your tests are flaky and slow. This is what that dashboard looks like. There's a bit.ly link where you can see it. In this case, it's for our own Gradle Enterprise instance, but you can sort it by which test is most flaky, which one's the shortest, which one fails most often. And yeah, with those columns right there. Cool. Random question, I always like to ask this in all my talks. How many people use Room? Awesome. Do you know about the Room cache miss? That it uses absolute path sensitivity. And if anyone has seen any of my other talks, I know I'm on repeat. But it's still an issue. It has overlapping inputs and outputs. It has a non-exclusive output directory. And the capt removes the contents of the output directories. These are just some of the issues. It's been around for a long time. I gave a talk about it last year. I just want to say, please upvote star like this issue so that maybe they can get on the radar of the Google team at some point in the next 5 years. All right. Yeah. OK. So yeah, just some other resources here. Here we have a link to those build validation scripts I was talking about, a link to the Gradle Enterprise API manual, as well as a sample using that Gradle Enterprise API. If you have any questions, feel free to use the Gradle community Slack. That's a link to the invite. We also have trainings available on our website if you want to learn more about Gradle, Gradle Enterprise, the build cache. It's all available there. Up there, there's a link to the slides. There's also, again, a link to the Room bug. We're hiring at Gradle Enterprise and Gradle across the board. My team is also hiring the solutions team. And yeah, these are the links to the slides and those links from earlier. So yeah. And now I'd like to open up the floor for questions. Thank you all very much for coming to my talk.